Okay, let's go ahead and do some examples with getting the equation of a function just from the graph, this time with a phase shift. So we've done this before without a phase shift, now we're going to do it with a phase shift, and we're going to see that it's not going to be a whole lot more complicated. Anyway, if you want to get a copy of this worksheet and follow along, you can check the video description here. There will be a link in there. Click the link. You can open up this worksheet and print it out and follow along if you'd like. So anyway, example 1, find an equation for the given graph. Write the equation as a sine function with a phase shift. So what's nice about this is we're being told to use a sine function. When we did it without a phase shift, we had to do a step where we determined is it sine or is it cosine. We had to do a little bit of work there. But now we're being told to use sine. Okay, so that's good. If we're not told, we can actually do either one we want. But if we look at this graph here, we see it kind of looks like a cosine turned upside down. So if we do it as a cosine, it won't have any phase shift. But we want to do it with a phase shift. And also the instructions say to do it as a sine. So anyway, neither here nor there, but we're just going to do it as a sine. So our answer is going to have this form here. Okay, y equals a sine omega x minus phi plus b. So that's going to be our answer, something like that. Okay, basically our goal now for this problem is to figure out what is a, what's b, what's omega, and what's phi. Okay, and then we're just going to plug them into this function here, and then that'll be our answer. Okay, so step 1, find the vertical shift b, if any. So this is actually exactly the same. Let's zoom in a little bit here. This step is actually exactly the same as without a phase shift. So find the vertical shift b. So how do we find b? Remember, b is the maximum plus the minimum divided by 2. Okay, so what does that mean? That means the maximum y value plus the minimum y value divided by 2. So if we look at our graph here, zoom back out just a bit, we see the largest y value is 3, it happens right about here. And the smallest y value is negative 3, it happens right about here. So then b is going to be the maximum 3 plus the minimum negative 3, all divided by 2. 3 plus negative 3 is 0, 0 over 2 is 0, so b equals 0. That's great. Okay, that's great. Oh, it doesn't really matter, I guess. So anyway, now step 2, find the phase shift phi over omega. So that's going to be a little bit different now. Now for step 2, the way we do step 2, it depends on whether we have a sine or a cosine. Okay, so in example 1 we have a sine, so we're just going to talk about that. When we get to example 2 in the next video, that'll be a cosine. We'll talk about how to do that one there. But here we have a sine function, so we're going to write that the equation is going to be a sine function with a phase shift. So since we have a sine function, here's how we do the phase shift. What we do is we ask ourselves, where do the x coordinates of 0, 0 go? Okay, so if that sounds like a goofy question, it kind of sort of is, but let's look at the graph of sine. Okay, so maybe we should zoom out just a bit here. Okay, so this is a graph of y equals sine of x, and this right here is the point 0, 0. Okay? So remember, a phase shift is a horizontal shift, so that means shift to the right or to the left, right? That's all a phase shift is. So what that changes is just the x coordinate. Okay, so a phase shift, horizontal shift to the right, to the left, that does not affect y coordinates at all. Okay, if you take this point, shift it to the right, you're going to have the same y coordinate. Okay, so that's why we ask ourselves, where did the x coordinate of 0, 0 go? Okay, so if we can determine where the x coordinate of this went, then we can figure out the phase shift. Okay, because that's going to tell us how far to the right or to the left that this graph moved. Okay, so that's why we asked that question. And also for a cosine, it's going to be a different question. We're actually going to ask it about 0, 1, but we'll see that in the next video. So we don't want to get too far ahead of ourselves. But anyway, again, because sine has 0, 0 on it, the graph has 0, 0 on it, we want to know where did that point move to. Okay? So let's look at this graph here. So we look at this graph here, we see, okay, 0, 0. So we're doing this as a sine function with a phase shift, so where did the point 0, 0 go? Well, here's 0, 0. Where did the x coordinate go? Well, just let's keep going along to the right, and then here's the point pi comma 0. Okay? So this is a distance of pi units. Okay? So now, first of all, you might be asking yourself, why did we go this way? Why didn't we use this point over here? Why didn't we go to the left? No reason. You absolutely, positively can do that if you want. And in fact, you can even use 3 pi if you wanted to. Okay? It does not matter. There are really infinitely many possibilities. But I went this way in the positive direction to the closest one. So usually that's, I like to go to the closest one, but these are both equally far away, so I just want to take the one in the positive direction. But there's another reason I chose this one too that we'll talk about soon. Anyway, where did the x-coordinate of 0, 0 go? It went pi units to the right. Okay. So the phase shift is pi. Okay. So what that means in terms of mathematical symbols is just, so let's come up here and write that. So this means that phi over omega equals pi. Okay, so find the phase shift phi over omega. Remember we talked about phase shift a lot. Phase shift is phi over omega. Okay. So here, where did the x-coordinate 0, 0 go? It went pi units to the right. Okay, we just saw that here. Okay. So the phase shift is pi. But again, you could have said it went pi units to the left. Okay, you could use this point. Then you could say the phase shift is negative pi. You could have used this point. So it went 3 pi units to the right. So then the phase shift is 3 pi. You absolutely, positively, totally could have said that. It's completely fine. It'll change things a little bit later on, but it does not matter at all. Okay. Okay, so that's it for step 2. Find the phase shift phi over omega. So that's kind of what's a little bit different with doing it with the phase shift, is you have more possibilities, which you also kind of do without a phase shift, but they're more complicated to see. Anyway, so that's it for step 2. Now step 3, find the amplitude, absolute value of A, and use it to determine A. That's kind of the same as without a phase shift. How do we get A, absolute value of A? Remember, that's going to be max minus the min divided by 2. Okay, max minus the min. So let's go ahead and do that. So absolute value of A equals the max, which we already know is 3, minus the min, which we know is negative 3, all divided by 2. Okay, so 3 minus negative 3 is positive 6. 6 over 2 is 3. Okay, so now A, absolute value of A, absolute value of A equals 3. So A equals 3, or A equals negative 3, right? Because these are the only two numbers that satisfy this condition here. Now we want to know, is it positive 3 or negative 3? So this is the part that's pretty much just like without a phase shift, but now what's different is we have to look at this point right here. Okay? So now on a regular old sine graph, let's zoom out a little bit here. On a regular old sine graph, the graph increases through 0, 0, right? It increases through 0, 0. Well, 0, 0, it went up and moved to pi comma 0. So now we're going to ask ourselves, does this graph increase through pi 0 or decrease through pi 0? Well, this graph increases through pi 0. Okay, so this is sort of like our base starting point. Just like 0, 0 could be the starting point, so you can go this way and then out that way. So we can think of this as our new 0, 0. Because we look, where did 0, 0 go? It went pi units to the right. So it increases, the graph increases through that point. So, so we say the graph increases through pi comma 0. So, maybe zoom in a little bit on this. The graph increases through pi comma 0, so A has to be positive. Okay, why does A have to be positive? Because y equals positive sine of x increases through 0, 0, and 0, 0 went up and moved to pi 0, okay? Now this would be completely different if we said negative pi 0. So if we use negative pi, that would change the phase shift, and also we'd be looking at negative pi 0 instead of pi 0, and we see that the graph decreases, so we would end up with a negative A. But here we're using this point here, so the graph increases, okay? So why would it change if it were decreasing? Well, because here, let's zoom out a bit. This is positive sine of x, so what would negative sine of x look like? Well, negative sine of x would just be this completely flipped upside down. So it would be kind of sort of something like this. So like that, upside down like that. Okay, so that's this one in green here. What a mess. So this is y equals negative sine of x. Okay? So we see that for negative sine of x in the green here, that decreases through 0, 0. Okay? So that's why if we use this other point, so this minus sign means the coefficient in the front has to be negative. Okay? But for plain old y equals positive sine of x, it increases through 0, 0. So here the graph is increasing through pi 0, so our coefficient out in front, the a, has to be positive. Okay, but if we were looking at this point instead, which we aren't, but if we were, then a would have to be negative, because the negative sign of x decreases there. Okay, so decrease, decrease, increase, increase, and we're using this point as our new reference point, or our point of interest. So since we increase there, then a is positive. Okay, so just a lot of details there. So again, you really do it the way you want, but that's another reason why I chose this one, because if I choose this one, then I increase through that point, and my a is going to be positive. Okay, that's good. So the thinking is a little bit different for cosine, as we'll see in the next example, maybe even a little simpler. But anyway, so a has to be 3 or a is negative 3, and also a has to be positive. So if you're positive and you're either 3 or negative 3, you have to be 3. Okay, so a equals 3. Okay, so a equals 3 and also b equals 0, let's circle that. So again, why is a 3? Well, absolute value of a, we determined from this, is positive 3, so that means a itself is positive 3 or negative 3. Okay, so we also know that because the graph increases through this point of interest here, that's our new 0, 0. Okay, where does 0, 0 go? It went to pi comma 0. Okay, so since the graph increases through there, then a has to be positive. Okay, so if a has to be positive, then the only thing a could be is 3. Okay, so that's it for a. Now I want to point out that the y-coordinate is only 0 because we have no vertical shift. If we had a vertical shift, then instead of 0, this would be whatever the value of b is. But in this case, b is 0, so we still have 0 there. But if b were like 2 or 3, so if, let's say if b were 2, then that would be 2 instead of 0. Okay, but anyway, neither here nor there. So anyway, step 4. Find omega from the period and use omega to find phi. So this is just a little bit different from how we did it before with no phase shift. But now what we do is look at the graph and get the period. Okay, so if we look at the graph, there's not a whole lot of stuff to work with here, but we see, if we start here, trace all the way around, then the pattern of the graph is going to start repeating after here. Okay, so if we follow along here, the pattern starts repeating. Okay, see that? It starts repeating there. So one complete cycle is going to be this guy here. So here's one complete cycle. So what's the length of that? Well, the length is going to be right minus left. So it's 3 pi minus negative pi. Okay, so this is one complete cycle. Okay, so it's period is 3 pi minus negative pi, okay, which is 3 pi plus pi, which is 4 pi. Okay, so the period there is 4 pi. Okay. So that's the first part of step 4. So really, it doesn't really explicitly say it, but find omega from the period. We have to have the period to do that. So we just look at the graph, get the period. And again, right minus left to get the distance between them. Okay, because the length of this cycle, the distance from here to here, that is the period. So do right minus left to get that distance. Okay. So t equals 4 pi. But also, remember in general, t equals 2 pi over omega. Really, it's the absolute value of omega, but just like without a phase shift, we don't have to worry about omega being negative, because if omega is negative, we could do some simplifications, use even odd properties. We have to be a little more careful because of the phi, okay, because of the phase shift. But still, we could use the even and odd properties to simplify, and also we worried about positive and negative with a, so we're okay. Is we could just take omega to be positive and it'll work out correctly for those reasons. Okay, so these two things together, they imply, okay, the double arrow means imply, that 4 pi equals 2 pi over omega. And again, why is that? Well, the period is 4 pi, the period is also 2 pi over omega. Since both of these equal the period, they have to equal each other. Okay? So multiply both sides by omega and divide both sides by 4 pi. Okay, zoom in a little bit here. So that's an omega right there. So then 4 pi cancels, pi is canceled, 2 goes into 4 twice, and then omega is canceled, we're left with the 1 on top. So then omega equals 1/2. Okay, so that's our omega. Now we're going to use omega to find phi. How do we use omega to find phi? That's actually not that bad. So we already know this. We know phi over omega is pi. Let's zoom out a little bit. Okay, we know phi over omega is pi, and omega is 1/2, so phi over omega equals pi. But omega is 1/2, so phi over 1/2 equals pi. Okay. So a couple different ways to think about that, but let's multiply both sides by 1/2. Okay, so here dividing by a half, multiply by a half to cancel, so cancel, cancel. So then phi equals pi over 2. Okay. Oops. Now another way we could have done that is said phi divided by 1/2, that's the same thing as 2 phi. So 2 phi equals pi, divide both sides by 2, then you get phi equals pi over 2. Okay, so two different ways of thinking about it. You get exactly the same thing either way. So now that's it for step 4. Step 5, not really a real step, just toss all the numbers into the equation. So a sine omega x minus phi plus b, a is 3. So let's kind of out of room a little bit, so we'll write it over here. Y equals, a is 3. So we have sine, what was omega again? Omega was 1/2. So omega x, that's 1/2 x. Minus phi, phi is pi over 2, okay, pi over 2. So minus pi over 2. And then plus b, but b was 0. So this is our answer here. Okay, so that's it for example 1 for getting the equation from a graph with a phase shift. So we see it's a little bit different from without a phase shift, but it's not really that much worse. So example 2 coming up in the next video. And again, here's our answer.